Hello students, welcome back. So now we are going to discuss about two different terms, okay, but then most of the students they usually mix them up. Okay, we are going to talk about two different terms. The first one is the oxidation number and the second one is the valency. Now, if I ask you a very simple example, let's take sodium for instance, the very first example, sodium. Sodium has the atomic number 11 and the electronic configuration is 2,8,1. So now if I ask you a question, what is the valency of sodium? The usual answers that students tend to give is that the valency is -1. The valency is +1. Okay. Similarly, if we ask chlorine whose atomic number is 17, electronic configuration is 2,8,7. Again, if we ask what is the valency of chlorine, the usual answer is the most common answer. I'm saying the most common answer comes out as that chlorine has a valency of -1. Okay, but then, my dear students, let me tell you, whatever you're doing as +1 and -1 or whatever you're saying, that's wrong. Valency, please remember a very important term or a very important thing about valency, that valency, it never comes, valency is always without charge. Okay, valency is just a number. Now, why valency is just a number? The reason for that is because valency just tells you, okay, so valency is the number of electrons lost, gained, or shared so as to complete an octet or a duplet. Okay, now what do you mean by an octet or a duplet? Octet means 8 electrons in the outermost shell, in the valence shell, and duplet means 2 electrons in the valence shell. Now, if I talk about sodium over here, sodium has 1 electron in the outermost shell, right? And because he has 1 electron, he has 2 options. So, the 2 options that he has is either he could lose 1 electron or he could gain 7 electrons. And definitely losing 1 electron is very simple, right? Rather than gaining 7, losing 1 makes sense. Losing 1 is very simple. So therefore, what is the valency of sodium? The valency of sodium is just 1. It's just 1. It's a number. Please remember. So what is the valency over here? The valency of sodium is 1. Similarly, if I talk about chlorine, chlorine has 7 electrons in its outermost shell. So again, this guy, chlorine, has 2 options. What are the 2 options? The first option is that chlorine could gain 1 electron, or the next option is he needs to lose 7 electrons. Okay, definitely gaining 1 electron makes sense. Okay, that's the most simplest option. So he would gain 1 electron. So again, the valency of chlorine would also become 1. Why? Because valency is just the number of electrons which an atom would gain, lose, or share so as to complete their octet, that is 8 electrons, or to complete a duplet, that is 2 electrons in their outermost shell. Okay, now let's understand what do you mean by oxidation number. So what do you mean by oxidation number? Oxidation number is nothing but, let me just put down some space. Okay, so what do you mean by oxidation number? Let's see. So oxidation number is nothing but the charge. Okay, understand, because the atom is losing electron or gaining electron, definitely he would get some charge, right? So over here, what I would say, oxidation number is nothing but the charge gained by an atom due to loss or gain of electron. Mind it, over here I am just saying loss or gain of electrons. I am not talking about sharing. This means that whenever atoms share electrons, they don't get charge. Please remember this. Whenever atoms share electrons, they don't get charged. And that's the reason this bond is referred as a non-electrovalent bond. And obviously the bond in which it gets charged is referred as electrovalent bond or an ionic bond. We'll learn about this in some other topic. Clear? Okay, so once again, what do you mean by oxidation number? Oxidation number is nothing but the charged gain by an atom due to the loss or gain of electron. Like for example, you always said that sodium has valency of +1. Why +1? Because if he is losing electron, would he gain a positive charge? The answer is yes. Okay, how much electron is he losing? He is losing 1 electron. So he would gain a positive charge of +1. Similarly, you always said that chlorine has a valency of -1. No, chlorine can't have a valency of -1. Valency is just a number. Chlorine has oxidation number of -1. Okay, so the magnitude of oxidation number and valency definitely remains same. But valency comes without any charge. Oxidation number comes with a charge. Now, talking about oxidation number, we need to understand that there are certain rules which are related to valency, or there are certain rules which are related to the distribution of electrons. Similarly, there are also some rules which are laid down for finding out the oxidation numbers. So you have some rules for finding oxidation number. Okay, and what are those rules? They are as follows. Okay, so you have pretty much like 5 or 6 rules to be very precise. Okay, I have not counted them, but then these are the basic rules that we need to follow while we are finding any oxidation number. Okay, now my suggestion to you is you please write down these rules in your notebook so that they would be in front of your eyes when we are going to solve the examples of finding the oxidation numbers. Okay, till then, let's discuss each rule. Let's give a quick understanding about each rule, and then we'll go ahead with the next part or the main part of the chapter, that is actually finding oxidation number. It's pretty interesting. Let's see. Okay, so let's start with the first rule. What does the first rule says? The first rule says that oxidation of any uncombined element is always 0. Okay, so what does the rule says? That whenever you have any uncombined element, okay, uncombined element as in, you can say you have sodium, you can say you have zinc, you can say you have iron, basically any element in its natural form. So whenever you have any element which is in its uncombined state, over here they have written S8. Okay, in nature sulfur is found as S8. So again, it is just combined with itself, right? So it's in its natural form. So definitely the oxidation number of such elements or such molecules will always remain 0. So whenever you have an oxidation number of any uncombined element, it would definitely come out to be 0. Okay, so that's one thing. Let's go on with the second rule. Okay, the second rule says over here that in compounds, many atoms or ions have fixed oxidation numbers. That is, if I'm talking about group 1 elements, which are the elements? Then group 1 elements are lithium, then sodium, then you have potassium, then rubidium, cesium, francium. Okay, all of these elements are group 1 elements, and group 1 elements, they will have oxidation number always equal to +1. Please remember this. Similarly, if you have group 2 elements like you could have beryllium, you could have magnesium, you could have calcium, strontium, barium, radon. All of these are group 2 elements, and group 2 elements will always have the oxidation state as +2. Similarly, if I talk about fluorine, fluorine is the most electronegative element, the topmost electronegative element. So fluorine would always gain electron. How much electrons? He would always gain 1 electron. So irrespective of whatever is the element attached to fluorine, fluorine would always have fluorine would always have the oxidation number as -1. Why is it so? Because fluorine is the most electronegative element. What do you mean by electronegative? Electronegativity means the tendency to gain electron. So fluorine is the most electronegative element, followed by oxygen. Okay, let's go further. The next one. If I talk about hydrogen, hydrogen has almost everywhere has the oxidation number of +1, except if bounded to or bonded to a metal. It can be a group 1 metal or a group 2 metal. Let's take an example. So for example, if I say that I have a compound NaH, that is sodium hydride. So in this case, sodium being a strong metal, sodium would always have the oxidation state as +1, and so hydrogen needs to have equal and opposite. Why equal and opposite? Because you need a molecule to be neutral, right? You can't have a molecule with a charge. You can have ion with charge, but you can't have a molecule with a charge, right? So if this is total +1, hydrogen needs to have -1, so that it becomes equal and opposite and it neutralizes each other. Okay, am I clear with this? Let's go further. Next point says that if I talk about oxygen, the second most electronegative element, who was the first most electronegative element? It was fluorine. So if I now talk about oxygen, the rule says that whenever in oxygen oxygen would always have the oxidation state of -2, except when bonded with fluorine. So when bonded with fluorine, fluorine will have -1 and oxygen needs to have positive. Similarly, when this same oxygen is bounded, or when this oxygen is in form of peroxide, we would discuss what exactly is peroxide, don't worry about it. So whenever it is bounded to a peroxide, it is always having an oxidation number of -1. Please remember this. Okay, usually oxygen has a oxidation number of -2, but when it is bonded with fluorine, it has an oxidation number of +1 or +2, whatever it might be, depending upon how many fluorines are attached. Okay, and whenever it is in form of a peroxide, it has to have an oxidation number of -1. Okay, similarly, if I talk about oxidation number of other elements, okay, that is other elements like halogens, chlorine, fluorine, iodine, bromine, if all of them are halogens, all of them are belonging to the same group, they would have the oxidation number as -1. So the next point that we can write over here, halogens have the oxidation numbers as +1. Sorry, my bad. I'm so sorry. Halogen has an oxidation number of -1. Obviously, depends on whom they are bonded. Like if fluorine is bonded to chlorine, fluorine has no other option. He has to have -1. So chlorine would gain +1. Okay. You would come to know as and when we do the examples. Okay. We'll deal with examples. We'll deal with a lot of examples. Okay. But then as and when we deal with the examples, that would be the time when most of the things would get clearer and clearer. So that's the reason I told you, please write down these rules. You don't need to by heart these rules. Slowly and steadily these rules would get imbibed because we would be using them so very often in our further course of chemistry. So you don't need to bother about exactly that, do we need to remember these rules and all that stuff. Okay, let's go with the next one. As I said, the fourth point, the sum of all the oxidation numbers in the compound needs to be 0. Why? Because you have a compound which is always neutral. Okay, so whenever you have a compound which is neutral, the sum of all the oxidation numbers in that compound needs to be 0. Pretty obvious point. Okay, the next one is important. Rather, the next two are important. So the next point says, we'll just read the point first. The next point says the sum of oxidation number in an ion is equal to the charge on the ion. Let me give you an example. So this point says that let's suppose I come across an ion, something like SO4 2-. So this says that the sum of all the oxidation numbers, that is oxidation number of sulfur plus oxidation number of oxygen into 4. Why into 4? Because I have 4 oxygens. Okay, so oxidation number of sulfur plus oxidation number of oxygen needs to be equal to the charge over the ion, that is equal to -2. So what does this point means? Which point? We are talking about the fifth point. The fifth point says the sum of oxidation numbers in an ion is always equal to the charge over that ion. Okay, what does this mean? That if I have an ion of SO4 2-, the oxidation number of sulfur, because there is only one sulfur, I don't need to multiply it with anyone, plus oxidation number of oxygen into 4. Why into 4? Because I have 4 oxygens, should be equal to the charge over the ion, and the charge was -2. Okay, the last and the final point, it says in either a compound or an ion, the more electronegative element is given the negative oxidation number. As I said, I know that oxygen loves to have -2 as the charge, as the oxidation number. But then let's suppose if you have, let's take an example. Let's say you have H2O. Okay, let me just change the color. It's becoming too much of red. Okay, so let's suppose if we have a molecule like H2O. So in this, what I would say, hydrogen, let's say I want to find out the oxidation state of hydrogen. How would I find out? Now, let's say the oxidation state of hydrogen is X. I don't know it. Let's assume I don't know it. Okay. How many hydrogens are there? There are in total 2 hydrogens. Okay. Plus, okay, what is the oxidation state of oxygen? Usually, it's always -2. So plus -2 should be equal to what? It should be equal to 0. Why it should be equal to 0? Because our molecule is always neutral. It doesn't have any charge over here, right? And because it doesn't have any charge over here, it is having a neutral charge, that is 0. So what would be my equation? My equation would become 2 into x plus -2 should be equal to 0. And therefore, what I would get is, I would get 2 into x is equal to 2. Therefore, x is equal to 1. That means the oxidation number of hydrogen is 1. But over here, the point that I was telling you is that oxygen has an oxidation state of -2. But then, if this same oxygen who loves to have an oxidation state of -2, let's suppose it is combined with a more electronegative element like fluorine. So in that case, what would happen? Let's take an example, something like OF2. Now over here, let's assume that I don't know the oxidation state of oxygen. So what I would do is I would form an equation. Oxygen, let the oxidation number be X, plus I know fluorine can never have anything other than -1. So I have -1. Because I have two fluorines, it would be into 2. That has to be equal to 0. If you solve this, I would get X minus 2 is equal to 0. Therefore, X is equal to plus 2. And now I get that same oxygen who was earlier having -2 as the oxidation state, now having an oxidation state of plus 2. So understand, the oxidation states will depend upon whichever element it is combined to. Obviously not for fluorine, because he's the topmost guy in that list, so no one could overpower that guy, and he has to have a -1 oxidation state. Okay, but other than that, for other elements, you need to understand that definitely I need to work upon how the elements are combined with each other, whether it is a metal or whether it is a non-metal, what exactly is the thing, and then I need to talk about the oxidation states. I hope this is clear. In the next part of this chapter, we will be talking about few examples of oxidation numbers, not few, quite a bit of examples of oxidation number, and we would also talk about whether the reaction is a redox or not a redox reaction. That is, we would be trying to find out whether the reaction is a redox reaction or not a redox reactions. So I hope we are clear till this point. Let's meet in the next part. Till then, thank you.